All right, today we're going to talk about section 5.4, logarithmic and exponential equations. A lot of this should be reviewed because if you remember last chapter we talked about logarithmic and exponential functions. So we looked at those graphs and we dealt with some things with those already. So a lot of this is stuff you should already know. This, remember, is how we go between logs and exponentials. You must be able to do this by this point. It's essential to solving these equations. We also learned, we looked at on page 204 in your book, these rules. These exponential rules you learned in Algebra 1, where if you're multiplying two bases that have exponents, as long as it's the same base, then you can add the exponents. Or if you're dividing them, you can subtract. Or if you have an exponent raised to another exponent, you multiply those two. That should have been solidified a long time ago. This one is from last chapter. We had a little trouble with this, so let's make sure we go back over it and make sure we understand it. If you have two things multiplied together and you're taking the log of that, you can separate it by adding the log of each of them. Or if you see that you have an addition of two logs of the same base, then you can come back and simplify it by putting them together as a product. For a quotient, we subtracted. And again, the same thing. If you see two logs subtracted with each other, then you can come back and put it into one log with the quotient. If you have a power on a log, that's a number out front. Again, if you see the number out front, you know you can put it back into this form. When you have an equal sign, you can go from one to the other back and forth. It doesn't have to only work one way. When you're solving equations that are logarithms or exponentials, it is essential that you simplify them first. You have to know all these rules so that you'll be able to simplify them so that you'll be able to solve them, because you'll need them in either single exponents or single logs whenever possible. Alright, so let's try one. Let's say we have a log base 5 of x plus 2. And that's equal to 3. Well, the first thing we want to look at is, do we have a single log? Where's my variables? My variable's in the log. The log is working on that. So I'm going to need to get rid of this log to be able to deal with that. So I look and see, well, do I have it all down to one single log? We do, in this case. So the easiest thing to do is to just move it to an exponential form. We know an exponential form, that means we take our base to the number on the other side of the equal sign equals what you're taking the log of. And now it's just a simple algebra problem. 5 cubed is 125. Then we subtract 2 from both sides. And we get that x equals 123. Not too difficult, right? Let's try an exponential one. What if we had 4 to the x squared power equals 1024? Well, we have an exponential here, and there's just one of them. So the easiest thing to do is to put it in log form. So we have our log of, remember, base of the exponent is the base of the log. Log of the thing on the other side of the equal sign equals whatever the exponent is. Well, log base 4 of 1024, you can put it in your calculator, and you get 5 equals x squared, which means x is plus or minus the square root of 5. Now, for this, remember, in your calculator, some of you, your calculator will do various bases, and some of you, they won't, which means you'll have to use a common log and do your change of base formula, where you take the common log of whatever you're taking the log of divided by the common log of the other base. Either way, you should end up with 5 as your answer, which gives us plus or minus the square root of 5 as the answer to this equation here. Let's try one that's a little bit harder. How about this? We have the log of x squared plus 3x minus 18 minus 2 times the log of x minus 3 equals the log of 4. The first thing I want to point out is these parentheses here mean you're taking the log of that whole thing. You have to figure out what that thing is first, and then you take the log of that. If you don't have parentheses, then you're only taking the log of the first little part that's right next to the log. So let's look. What do we have? Well, we've got this number out front, and we've got this subtraction sign. Those two things should clue you in immediately that you can simplify this down. They're all the same base logs. These are all common logs, so we can put them together. Let's start with using this number out front. That's a power rule. So we just move it up as an exponent. Then we've got the subtraction sign. A subtraction sign between two logs of the same base should immediately tell you, okay, that means they're a quotient and I can put them together. So we take the first one on the top and then the bottom one. Now this is a rational equation, a rational function. You're taking the log of a rational function. So we need to simplify that first. The top factors nicely. So we can now see that we can simplify that further by canceling things out. You also notice we're taking the log of both sides. So if you're going to take the log of both sides, then whatever you're taking the log of on both those sides have to be equal to each other. So we really don't need the logs anymore. We can just say that x plus 6 over x minus 3 has to equal 4. Make sure you think about that and understand it. Taking the log of both sides means that we're taking the log of the same things if they're equal to each other. So now we have just an algebra problem, and we multiply our 4 times our x minus 3, and then simplify. We get 18 equals 3x, and x equals 6. And there's our answer. All right, let's try one last problem. Sometimes you're going to have exponentials, and you're not going to be able to get them where we can just set their exponents equal to each other because they're not the same base. There's no way for us to get this the same base. 6, you can't simplify that to 3 to some power. So what we're going to do, if you have two exponentials like this, and we need to solve for the variables and their exponents, what you can do is take the log of both sides. Just like adding or subtracting or multiplying, if you take the log of both sides, then you still have kept it the same. Now we can use our power rules. We have the variables down where we can work with them. Excuse me. Now, if we plug this in our calculator, what the log of 6 is, we get that it's 0.778 approximately. So we distribute that. And if we do the log of 3 and then multiply it times 2, we end up with 0.954x. Now with a little rearranging, we end up with x is approximately equal to negative 4.419. So taking the log of both sides is definitely an option. Just remember, when you're changing an equation by doing something to it, whatever you do to one side, you've got to do to the other. And that works with logs as well as other things. So, in summary, for logs, you want to try to get it to a single log. Then change it to exponential. And solve it. For exponentials, if there's only one of them, then you can change it to log form and solve it. But if there's more, you can take the log of both sides and solve. So, the biggest thing with this is all those log rules we learned last chapter, you really have got to have down. Whatever pictures you have to draw in your notes, whatever songs you need to make up, whatever flashcards you need to go through, you've got to know those. Work on those diligently and make sure you've got them all by next class. Make sure you have notes and you've read over this section so that we can go over it the next time we meet.